How's it going, everybody? In this video, I wanted to introduce and break down some of the inter-AS MPLS Layer 3 VPN topics that we're going to be covering in this section. Now, you've already probably seen the MPLS Layer 3 VPN, the intra-AS variation of that, where we covered a lot of different scenarios with MPLS Layer 3 VPN. Covered all the IGPs, IPv4, IPv6, and things like that. We didn't go into a lot of specialities, like we didn't do internet as a service or overlapping VPNs or management VPNs or anything like that. That'll come later on down the road because it's not quite as super centric. But I want to cover I want to keep going with this because at least at the time of this recording, in light of all the pandemic that's happening right now that everybody's being affected by, I'm still studying. You still have to keep studying. So with that being said, I don't know when I'm going to be able to go back to reattempt the CCIE Service Provider Lab exam, but that doesn't mean that myself or anybody else shouldn't keep trying to keep leveling up and doing their thing. So that's what I'm going to do in this video. So I'm going to go ahead and I'm going to grab my pen tool and we're going to start whiteboarding this out so you guys understand what's actually happening. So let's go ahead and start breaking down what actually is going to be covered in this section. So there are technically four main, actually let me go ahead and bump this up to be a little bit thicker. There are four main ways of implementing what they refer to as inter-AS or inter-autonomous system MPLS Layer 3 VPNs. Okay, the first one is going to be option A. It's supposed to be OPT A, which is your back-to-back VRF. Option 2 or option B is a VPN v4 slash v6 eBGP peering back to back ASBR. The third one is going to be option C. Again, I gotta remember to finish that out, which is going to be a multi-hop eBGP route reflector to route reflector peering. Now, and then number 4, or option D, which is also referred to as A/B because it uses both A and B logic, which is going to be a hybrid approach where you're doing a combination of both A and B, where the control plane is option B, the data plane is option A. That's the basics to it. Now, this is what we're going to be focusing on as we initially go through this. I'll be covering option D last, but it's one of the, as we get there, we'll definitely take a look at how that works. But the way that we're going to be approaching these different ways of doing this is in a crawl, walk, run approach. So right now, the only thing that's configured on the topology behind me and above my head happens to be blank configuration, other than the IP addressing is done, and only the IP addressing in certain areas is done, only the core portions of it. Like literally, that's all I've done. So we're literally going to have to walk through all the config. So we're going to do a base config, which won't be tied to any specific option. We'll talk about setting up the IGP and the LDP and all of that type of stuff. All of that will happen first so that we can bring you guys up to speed. So if you've already been familiar with doing regular MPLS Layer 3 VPN, this will be no big deal because it's basically essentially what you're trying to accomplish. That's it. Now, once we get IGP, LDP, VPN v4, VPN v6, VRFs defined, and all that type of stuff, then we will be able to transition and start focusing on the different options. So the way that I'm planning on doing this is it'll be the implementation that we're going to be walking through, and there's going to be a lot to talk about. Initially, it's going to be 1, 2, 3, and 4 is going to be normal intra AS layer 3 VPN, meaning we're going to have to run an IGP of some type inside of the core. We're going to have to run BGP in the core to interconnect the PE routers and things like that. Then we're going to have to get VPN before peerings to work. We're going to have to create VRFs on the provider edge routers and all that type of stuff. Then once we have all of the core MPLS layer 3 VPN stuff in play, then we'll be able to start looking at the specific configurations that need to be done on a per option basis. So that means that the ASBRs for option A will need to have VRFs created on them. And all these interfaces right here, all these all these subnets will have to get placed inside of VRFs. And we'll be able to segment the network that way. And then when we get into option B and all the different things that will come into play with that. So that's going to be the game plan here. So what I want to do is I want to lay out some groundwork to help everybody understand some of the terms that we're going to be going through and understanding. Now, take your normal MPLS Layer 3 VPN design that you're already familiar with. Now, if you're not already familiar with it, that's okay. We're literally going to set this up from ground zero and get ourselves to the point where you normally would be having an MPLS Layer 3 VPN working with inside of the same autonomous system. All that stuff still has to work. That doesn't just go away. It still has to be there. That's why that's kind of like your base. If you're not there already with your MPLS design, then you need to get there. And I suggest you do that with BGP as the PE to CE routing protocol. Now we take that same logic, and one of the things that's going to end up happening is we have some terminology shifts. So the first terminology shift is this will no longer be referred to as a provider edge. Now, when we're talking about the provider edge, that connects down to a customer, right? This is a provider edge right here, right? This will no longer be a provider edge. This will be now referred to as let me go ahead and just remove this part right here. This is a provider edge. This is a provider core. This, a CSR5, for example, this guy right here, he will be referred to as an ASBR. And you might be thinking to yourself, well, gee, Rob, isn't ASBR is an OSPF external routing thing, right? Yes, it is. But it also is applicable here in this design. What it simply means is it's a router that's at the edge of your MPLS Layer 3 VPN domain that connects to another service provider. That's all. It's a boundary router. Now, the way that we would correlate this is two ASBRs peer with each other, like this. Then you've got communication going back and forth between the two to get to where everybody's got to go. So this would be an ASBR as well. And then these guys would be ASBRs. And this would be an ASBR. So on and so forth. You still have your normal provider edge routers set up here. These would be PEs. And we're going to have 3 separate customers. And this will allow us to scale this out and play around with it. Now, initially when we start going through this, I'm going to be focusing primarily on the key competencies that you need to understand about how this works. So I'll be focusing on pretty specific stuff like with option A, I'm going to do BGP. With option B and C and D, I'm going to do BGP. And the reason why I'm going to stick with BGP initially is because that's the most common thing I've ever seen in production. So for those of you that need to focus on BGP specifically, there you go. Now, in the event that you need to switch over to a different routing protocol, so whether it's static routing or an IGP between the autonomous system boundary routers or the ASBRs, at that point in time, you can then transition over back to option A, and we can focus on that, which we will be taking a look at. Recording-wise, you won't really notice anything inside of the YouTube playlist, but I'm planning on recording them kind of out of order on purpose. to try to get through the majority of what's actually happening. So that means when we start taking a look at option A, and we're dealing with BGP, what we're going to be able to enable with that is going to be the best path selection process. So for option A, B, C, and D, we're going to be able to do things like local preference. We'll be able to do things like MED, or multi-exit discriminator. We'll be able to do AS path prepending and things of that nature. These are the big wins that you get when you leverage BGP over some sort of other IGP. And that's the goal here, is to play around with this and understand all the details. So let's go ahead and break down kind of what is going to go on with all the setup and how it's actually going to come into play and all that type of stuff. So let's talk briefly at a high level what's going to end up happening. So let me go ahead. I'm going to pause the video and I'll bring you guys back in here in just a moment. So when we talk about option A, what will end up happening is you have this interface right here, gig 3, for example, and you got these 4 prefixes associated to this. This main one here, 12.5.6.0/24, this will be associated to the main interface. This one specifically, the 12 dot whatever address range between the ASBRs, that one will be specific for the global routing table. Okay, so there will be a point in time when we have to leverage the global routing table, but we won't be using IPv4 unicast specifically. We'll be dealing with something in the, not in a VRF. So option B, option C, etc. Those will come into play. Now, these other ones here, 101, 102, and 103.5.6, and .5.6, these will be VRF aware specifically. So this means that when we take a look at how this rolls out, we'll have customer 1, customer 2, and customer 3, which will be VRF1, VRF2, and VRF3. This will allow us to segment the connections between the ASBRs when we start doing multiple customers. So we won't just do a couple of examples on we won't go through option A and get it all up and running and then boom, we're done. We're going to scale it out. We're going to have multiple customers and take a look at exactly how all that comes into play and that type of stuff. Because it'll be important to understand how those details operate and work. Now, option A is actually the easiest barrier to entry when it comes to the layer 3 VPN construct, because what ends up happening is you draw a logical line between on the ASBRs on both sides, and basically the connections between them, the ASBR treats the other ASBR, so this guy right here treats this guy right here as a customer edge router. So just how this guy right here sees this guy right here as a CE, and this guy here is a PE, we're basically applying the same logic here, where this guy would be a PE and this guy would be a CE. The difference between the two is the other side, so CSR5 and CSR6 go to peer with each other. That's okay, because at that point, we would have the ability to form the peerings and get everything up and running. The connectivity between them is just an IP routed connection, regardless of how you want to carve it up. So it's going to be IP forwarded. There's not going to be any labeling involved with this. This is why I say it's the easiest barrier to entry, because you're not really changing anything that you already know about MPLS Layer 3 VPN. What you're doing is you're taking the conceptual idea of the PE to CE logic, but the other end of the connection isn't a CE. It's another provider edge router, but belongs to another AS, another autonomous system, another internet provider. So that's the real win here when it comes to the barrier to entry. It's easy to understand and implement. Now, so you have a labeled path from here to here, for example, and then you would switch colors over to yellow-green, and this would be a IP path, and then you switch back to yellow, and this would be a labeled path. So it's label, and then IP. And you wouldn't know, you would be none the wiser on its operation. The trace route shows that there's no label and all that type of stuff. And I won't get into the minute details of what the label switch path should look like or anything like that. We'll see that when we actually get it up and running. Now the next one that we're going to talk about is going to be option B. Let's go. I'm going to go ahead and pause and clear this up. Now option B is a little bit different, where option B, instead of configuring the VRFs, you shut them down, and then you use the global internet routing table. So, but you're not using IPv4 unicast. You're using VPN v4 unicast, or VPN v6. We'll take a look at both. So, because v6 is supported across the wire as well. But the point being here is that when you look at it from the perspective of a forwarding capacity, both V4 and V6 are both supported, but we want to focus on the operations. What's the design of B trying to accomplish? So you form a peering between these guys with the VPN v4 address family. So on this particular prefix, you would enable the VPN v4 unicast address family on there, and what that's going to do is it's going to allow a label to be associated here. So from here to here will be a one labeled hop. Okay. Now from here to here, this will be a labeled hop, and from here to here, this will be a labeled hop. So that means in this particular case, you're going to have a 1, 2, 3 labels. That's the traditional standard. Now, there are some caveats to this when we talk about how you would implement this. So we're going to take a look at a couple of variations of this. Typically, you get the 3 label hop, or the 3 label stack, or the 3 LSPs, depending on how to look at it. And typically, you get 3 is when you use the next hop self option on the ASBR. So what's going to end up happening when you do all this is you're going to have to enable the connections back and forth, and we're going to assume that the ASBRs have no VRF created on them. So you'll have to do something on the ASBR. You'll have to do one of 3 things. So the first one will be either create a VRF creation, which will allow the routes from the route reflector to get sent up, or from the full mesh design, depending on how you want to go do it, to accept the BGP extended community value. Okay. Now, the second option, and if you don't create the VRF, it'll simply drop these the BGP community values, because they are they're an extended community value. So if you're not doing a route target import on the ASBR, it simply is going to drop them. The other option here is going to be to create the ASBR as a route reflector. And this way here, that regardless of what's learned from CSR5, or regardless of what's learned from CSR6, or inbound on CSR5 from router 5, it's going to become a route reflector. And that will allow you to learn the updates inbound. Now, if this guy right here is just a route reflector, client, then that's not good enough. He would have to have this guy right here would have to be a route reflector. So he has to be a route reflector himself, and then route reflector 1 would have to be a client of CSR5, and then he'd be able to receive the routes. So that's the other option. And then the third is going to be the route target filter option, which needs to be disabled. So either one of these solutions, 1, 2, or 3, are viable. And if you do the route reflector design, you don't need 1 or 3. If you do number 1, you don't need 2 or 3. If you do router or option 3, you don't need 1 or 2. So you don't need one in order for the other one to work. Okay, just make sure we're clear on that. Now, with that being said, once you receive this information inbound, that's going to go to this route reflector here, and then pump it up to the PE routers. You're still going to need to set the route target import here. So you're still going to need to import the route targets from the remote PE routers in the other autonomous system. So let's say this is 2 2:1, for example, you're going to need to do a route target import for 2:1. And this guy here is 1:1, for example. This guy right here will have to import 1:1 on this guy. You might say, well, what is that needed for? That's needed to allow them to import the prefixes from the ASBR as they're coming inbound. Now, the last step here is, because this is an eBGP peering, by default, the next hop is going to be set to this side right here. So it'll be 12.5.6.6 for anything that CSR1 learns from CSR5. So, for example, if I learn the 101.8.25.0/24 over here on CSR1 via the exchange, I'm going to see 12.5.6.6, or this guy's interface IP, as my next hop, and I won't be able to reach that. So I can use next hop self. That terminates an LSP on the ASBR and then creates another LSP between 5 and 6, and then another one from 6 to 8 internally here inside of this provider. There is another way of doing this, and you could basically take this prefix 12.5.6.0/24 and you can inject it. So basically turn the routing process internally. So for example, if this guy's running OSPF and this guy's running ISIS, you can basically turn OSPF on gig 3, and then that will allow that prefix to be originated into IGP, and therefore your routers internally through IGP will then know how to reach that particular prefix, and so you'll inject it. We'll take a look at exactly how that will affect it and when we get to that point. So there's a couple ways of doing it. Now, that's option B. Option B is rather involved. There's a lot of moving parts to it, but once you understand the steps, it's actually pretty easy to work with. Let's go ahead and take a look at option C now. Now, option C is very similar in logic to the connectivity between, for option B, where you have your VPN v4 peering between 5 and 6 on this segment here. But instead of doing that in VPN v4, you do that with IPv4. But what you're doing is you're adding a label. And what you're doing is a label between these two guys. And what that label is used to do is used to build a label switch path. Instead of there being 1, 2, 3 LSPs for option B, you're now eliminating 2 of those LSPs, and you're creating one consistent LSP through that. Or maybe if we were just to draw it this way, this would be the LSP. You would draw this to where it's got to go. Actually, it would stop right here on that guy. And the idea is when you do the labeled unicast peering between 5 and 6, and again, I know I haven't really touched on XR. These are supported in XR as well. What you would end up doing is you would either through local propagation through VPN v4 unicast, or whatever the case might be, or underneath the IPv4 unicast address family, you need to basically take the loopback address of the PE routers here, and here, and the route reflectors. They need to be originated into BGP so that they can go ahead and be propagated between the providers. So that means that 2 would know about CSR1, CSR2, and then route reflector 1. And then this guy over here would know about CSR8, XR16, and then route reflector 2. You would exchange the information, and then what you would do between the route reflectors is you would form a VPN v4/v6 eBGP multi-hop peering. And that would be done to allow the VPN v4 exchange between the route reflectors, and then that information would get pumped down to their respective PE routers, and then these guys would actually exchange information with each other. So these guys right here would be exchanging information with each other as well. And by doing that, you would go through and you'd be able to build an end-to-end label switch path. This is the most complex version when you're dealing with two different service providers. This is the most complicated way of doing it. Now it's only complex because there's a lot of capabilities that come into play. One of the main reasons why it's more complicated than option A and option B is because now when I go to learn an update from router 1 from router 2, this actually would be my termination point for an LSP. So instead of my traffic going, let's take this path right here, instead of it taking, let's go to red, instead of it taking, the path that it would take initially would be taking this, I'm sorry, it would come over here, it would get dropped off, let me switch to a little bit bigger so you guys can see it a little easier. It would get terminated here and get dropped off on the route reflector, and then another LSP would get you to the endpoint. Actually, let's do it this way. It would actually be set up like this one, and then another one here. So you have one LSP here, and then you have a second LSP here. Now, what would end up happening is you'd have to tell the route reflectors on both sides to do the no next hop. What's that command? No next hop self. There's a command. I can't remember exactly the exact syntax, but I'll know when we get there. But basically, what you're doing is you're telling. I'm sorry. Next hop unchanged. It's next hop unchanged. Don't point yourself to the route reflector in the other autonomous system as the end of your label switch path. And what you want to do is you want to type in next hop unchanged, and you want your LSP to be directly to the ASB or the egress PE router in the other autonomous system. Now, when option B and option C are going to be the two ways that you would actually go through and do a lot of advanced BGP traffic engineering. And that's where we're going to spend a significant amount of our time, is doing the traffic engineering in that respect. So there's a lot of cool stuff in terms of how this all comes into play, and that's really what you need to understand. Option A and option B, basically the same thing as, option D, which is a combination of option A and B, same forwarding structure there. We'll cover that when we get to that point. I really haven't dealt with it a whole lot, but we'll definitely take a look at it in this series of videos. So that's it. I mean, it's a lot to talk about, a lot to take in. But beyond that, the only other thing that I haven't mentioned about option C, is you'll have to make sure to do the route target import from the remote PE router. You'll have to make sure to import those route target values. Now, technically, there is another way of doing this. We haven't gotten to this part yet because it's more complicated than option A, B, and C, and D, and that's referred to as, get out of the way here, carrier supporting carrier, which basically adds another level of hierarchy to your design. And I'm going to talk about that in its own dedicated section. It'll still be inter-AS MPLS layer 3 VPN, but I'm going to add in carrier supporting carrier down the road, only because the fact that it's way more involved than these ones, because these ones right here typically are doing two service providers, but you could technically do this across multiple service providers. You could scale this out 3, 4, 5 of them if you needed to, but regardless of how you want to carve it up, this is how you would go about doing all of that type of stuff. So we're going to walk through in the next several videos and getting everything up and running. I'm going to try to keep the videos rather short and on point to get them up and running, walk you through the logic when we get to that specific point, and talk about those details then. Beyond that, guys, that's pretty much all I have for you in this video. I want to thank you guys for hanging out with me in this video, and until next time, take it easy.